happened when billiard ball bounced? All right, let me assume that I have head-on collision between the white cue ball and the 11 ball initially at rest. Okay, don't worry about the spin of the ball. So the 11 ball's final momentum is equal to the cue ball's initial momentum. That means momentum is conserved. Alright, so what's happening here? Let's look at the situation. This ball, the white ball, hitting the 11 ball. So the 11 ball was stationary, not moving. It's moving with velocity. It hits the 11 balls. The white ball is going to be here, it's going to stop. The 11 ball is going to move. Is that elastic collision, perfectly elastic collision, partially elastic, or inelastic? What's your pick? Partial? What do you say? Partial? Any other answer? It's perfect, because as I said here, this ball is moving, this is stationary. This ball is moving, it's hit the other ball, this is stopped, this is moved. So it's interchange in the velocity. Velocity final is going to be equal to velocity initial. So this is perfectly elastic collision. Perfectly, because that one stopped. If this one didn't stop, if the white ball didn't stop, if it kept going, then that's partially inelastic. But it didn't stop. It's just exchange in the velocity. Make sense? Exchange in velocity. That's it. All right. So perfectly elastic in this case. All right. Maybe you have seen this when you go shopping in the shopping malls. You see this. That's billiard. Well, similar to billiard balls. You can look at this. It's also perfectly elastic. How? Well, when you displace one of them, displace it here, and let it go, it's going to come here, it's going to hit that, it's going to stop. The other one is going to move with almost same velocity. It's going to move. And so forth. If you take two of them and let it go, they're going to hit the system. Two of them is going to go up with the same velocity. So this case is also perfectly elastic. And that's also looking at the momentum case. Alright? Any question on this? Okay? Looking at this case, this is in 2 dimensions. Football affair. The brown football player moving at the, I don't know, moving at the right, and the other one, the green one, moving at up, and they hit each other. Each one with his own momentum. So the momentum here 500 kilograms meters per second for this guy. The other guy is 300 kilograms meters per second. So what will happen here after the collision? After the collision, they moved, as you see, in what direction? They moved in this direction. If you want to look at the vectors, this guy is moving with it has momentum of 500 kilogram meters per second. That guy is up 300. So this is the resultant. This is where they're gonna move after they collide. That means here. This is the motion here. But let me ask you this: is the motion? If you want to look at the triangle, let's say if this guy is 500 kilograms meters per second and the other one is 500 kilograms meters per second, where do you think this component is going to be? At what angle? As you see the angle here, 31. Let me give you the choices. 31, 45, 50, 60. What's your choice? What is it? 45, definitely, because this momentum is same as that, so definitely they're gonna move with 45. But here, as you see it, is going towards this side, towards the x more than the y, because this guy has more momentum than the other guy. So that's why you see the triangle going towards the x-axis, not towards the y-axis. So if this guy has higher momentum, then definitely it's going to be towards this guy, towards the y-axis more than the x-axis. Keep that in your mind. Let's look at this case. Two lumps of a clay of equal mass are traveling at right angles with equal speeds as shown. When they collide and stick together, is it possible that their final velocity vector is in the direction shown? What do you think? Is this correct? This is before, this is after the collision. This is the direction after the collision. Is this correct or not? No? Why? Well, how do you correct it if it is not correct? Definitely, yeah. Same velocity. V1 is equal to V2. Again, this should be going at 45, and this is 45. Okay? Next thing. Yeah, so next thing. Two cars of equal mass collide at right angles to one another at an intersection. Their direction of motion after the collision is as shown. Which car had the greater velocity before the collision? What do you think? Is it the blue car or the red car has a greater velocity? A or B? B has a greater velocity. What do you say, guys? A? Yeah, I would choose A because as you see here, the direction here after the collision is towards the X, not towards the Y. So this is speeding. This guy is speeding. And this is how it comes with the investigation. Sometimes the police would know which car is speeding. Let's say at the intersection, you're going to see the red light. So somebody has to stop. And then when it turns to green light for this person, for example, he's going to move. Right? But he's not going to move as fast. When you start the car, it's going to move slowly and then you pick up the speed. But how about somebody else moving at the intersection? You want to cut the red light. The light turned red, so he has to stop. But he didn't do that. He went with the same speed. So what happened? They're going to collide. This guy is faster. He's going to move towards the faster person, faster car. And definitely this guy is at fault. That's why sometimes the smart police would know. Smart police who took physics with me, he should know which person is at fault. Okay, and maybe that's a tool for you. God forbid if you got involved in an accident and somebody cut the red light, then you could talk to the police. You could tell them that whatever. Yeah, why not? All right. I believe that's it with the power.